In problem 15, we're asked which expression represents f of g of x. This means we're plugging g of x into f of x. So if we take g of x, which is x plus 2, and we plug it into the x in our f of x, let's see what we get. So f of g of x gives us 2 times, plugging x plus 2 in place of the x, gives us 2 times the quantity x plus 2 squared plus 6. Now, mistake that is commonly made to avoid here is to not think that x plus 2 quantity squared is x squared plus 4. This is not correct. So please don't make this mistake of trying to distribute the exponent. So I'm going to cross this out to show this is not correct. Rather, the correct way to simplify this is to multiply x plus 2 times x plus 2. So if we do that, we need to multiply these two binomials together, which gives us 2 times the quantity x squared plus 4x plus 4. And then don't forget about the 6. Distributing the 2, we get 2 times x squared, so 2x squared plus 8x plus 8, and then plus 6. Combining like terms gives us 2x squared plus 8x plus 14, which is option B. In problem 16, we need to figure out which graph has a vertex as its maximum value. Looking at these options here, let's highlight one concept that's important to understand here. We have either our a value negative or less than 0, which would be a parabola which opens down. Or we have a values that are greater than 0, positive, which gives us a parabola that opens up. When you have a parabola that opens down, you have a maximum as your vertex. With a parabola that opens up, the vertex is at a minimum. So looking at the question again, which of the following equations has a graph where the vertex is a maximum? We need to look for which of these problems has an a value that is negative. The only equation that has an a value that is negative is option A. All of the rest of these options have positive a values. Problem 17. We have a system of 3 equations, and there's different orders in which you can solve this. I'm going to show you one example of solving this system of 3 equations. So step 1 in solving a system of equations is always to eliminate one variable by first taking only 2 of the equations. So I'm going to first choose to take the first 2 equations, and you choose any variable to eliminate. It looks here like x would be fairly simple to eliminate, so I'm going to multiply the first equation by 2 to eliminate the x. Okay, here's my new equation combined with this equation. Added together gives me negative 2y minus 7z equals negative 18. Step 2 would be to take another pair of equations and eliminate the same variable. So it looks like it would be fairly simple to use the first and the third equation. So I'm going to rewrite those. And we need to eliminate the same variable that we eliminated the first time around. So in this case, the x's can be eliminated by multiplying the first equation by negative 5. So that gives us 5x plus 15y plus 5z equals 35. Combining those 2 equations gives me, this gives me 13y plus 8z equals 42. So we now have 2 equations that both have the same variables, y and z. So step 3 is to take those 2 equations, I'm going to rewrite them, and solve this system of 2 equations with 2 unknowns. So we need to solve for y and z. So if we decide to eliminate the y first, let's multiply this by 13 and multiply this by 2. That gives me negative 26y minus 91z equals negative 234. And the second equation gives me positive 26y plus 16z equals 84. So we have now eliminated the y's. This gives me negative 75z equals negative 150. Z equals positive 2. Now when you're dealing with the multiple choice question, you may not have to solve the entire problem. So let's look at our answer choices here. If z is equal to 2, there's only one option which gives me a z value equal to 2, which is answer B. I'm going to continue to solve the problem just to show you that the x and the y values do end up being these. But remember that that could be a shortcut, is once you know one of the variables, you can check to see which answer makes sense. So plugging z back into either of our equations that have a y and z, you can solve for y. So taking this equation, I can plug in z equal to 2 and solve for y. So negative 2y minus 14 equals negative 18. So y is equal to 2. Our very last step, now that we know z and y, is to find x. So going back to our original problem, we can use any of these three equations to calculate x since we know what y and z are. So taking this first equation, negative x minus 3y minus z equals negative 7. Negative 6 minus 2 is negative 8. So x equals negative 1. So double checking our answer here, x is negative 1, y is 2, and z is also 2. In problem number 18, we have an absolute value inequality. An absolute value inequality, we need to write two inequalities. 3y minus 17 is less than 4. Our second inequality, we need to switch the inequality sign and make the 4 a negative. So remember those two changes, switch the inequality sign and make the 4 a negative. So now we solve the two inequalities. So we have y is less than 7 and y is greater than 13 over 3, which is answer B. In problem 19, we need to approximate the answer to this problem using our skills that we've learned in logs. This log equation can be changed to exponential form, 5 to the w equals 22. Well, we don't know exactly what w is equal to, but we do know that 5 to the first power is equal to 5. We also know 5 to the second power is equal to 25. This is somewhere in between an exponent of 1 and an exponent of 2. So if we know that w is somewhere between 1 and 2, there's only one option here that would make sense, which is option A, since 1.9 is somewhere between 1 and 2. And our answer is somewhere between 5 and 25. In problem 20, we find the inverse of the function. So first step is to change our f of x to y. And the definition of an inverse is that the x and the y values are switched. So if we replace the y with x and replace the x with y, we can then isolate the y to find the inverse function. So subtract 7 from both sides. So x minus 7 equals 6y. And we need to divide by 6 across to isolate the y. So we have y equals x over 6 is equivalent to 1/6 x. So our inverse function is 1/6 x minus 7/6, which is option B.